Now, in many instances in the laboratory, we would like to create solutions of known molarity from stock solutions that are usually of a higher concentration. So I will either purchase or make a stock solution that has a relatively high concentration of a given solute, and then I will dilute it to the appropriate concentration for my experiment or for whatever purposes I need. Okay, and so dilution is simply adding solvent, which usually we're talking about water, to decrease the concentration of a solute within my solution. So when we do this, the amount of the solute that we measure stays the same, but the volume increases, so the concentration increases. And so one way we do this in the laboratories, I may, for example, use a pipette to add some high concentration of a stock solution, and then I'll add deionized water to a known volume to end up with a final lower concentration. Right? So this is dilution. Now, when we're using molarity, calculating the concentrations that we arrive at from through a dilution, or calculating the amount of a stock solution that I need to make a known volume of a lower concentration, is relatively straightforward, because we know that the molarity, here represented by the capital M, times the volume in liters will give us moles. And so we use this dilution equation, which is M1 V1 equals M2 V2. That is the molarity of my initial solution times the volume of that initial solution is equal to the molarity of my resulting diluted solution times the volume of that diluted solution. So V2 is bigger than V1, and therefore M2 must be less than M1. Okay, and so it takes, we basically are saying that because the number of moles does not change and the volume increases, we can calculate these. Now, the units that we use actually don't really matter as long as we are consistent. For example, the M here, representing molar concentration, that doesn't have to be molarity. In fact, it could be millimolar, it could be grams per liter, it could be parts per million, it could be a percent by mass, it could really be anything, as long as we're using the same units on the left and the right. Same holds true with volume, whether we're using liters or milliliters or gallons, as long as we're using the same units on the left and the right. It really doesn't matter, as long as we're labeling those units. Okay, so let's do a very quick example here. If I need to make a 1 molar solution of acetic acid, and I need 500 milliliters, or a half a liter of that, and I'm starting off with a stock solution of glacial acetic acid, which has a concentration of 17.5 molar. That is, there are 17.5 moles of acetic acid for every 1 liter of solution. Well, to do this, I'm going to use my dilution equation. I'm going to say that M1 V1, the concentration and volume of my initial stock solution, is equal to M2 V2. So we know that here M1 is 17.5 molar. M2 is what I want, is 1.00 molar. And V2, the volume I need to make, is 500 milliliters. Now again, the volume units don't really matter, so I don't need to do any conversions here as long as I don't mind my answer being in milliliters. So I'm going to rearrange my dilution equation to solve for V1. V1 is M2 V2 over M1. So it's simply 1.00 molar times 500 milliliters divided by 17.5 molar. So when I do this calculation, I find that the volume of acetic acid that I need, right, that's what the question is asking, what volume of this 17.5 molar solution do I need to make 500 mils of 1 mole? Okay, so I just take 1 times 500 divided by 17.5, telling me I need 28.6 milliliters of that glacial acetic acid, that high concentration of acetic acid. I will then take that 28.6 milliliters, dilute it with deionized water to my final volume of 500 milliliters, and I have a half a liter of 1 molar solution. So this dilution equation is very useful, and again we can use it for any units whatsoever of concentration and of volume, as long as we're consistent with those units. So if I have milliliters on one side, I need to use milliliters on the other. If I use liters, I have to stick with liters.